Optimizing Network Experience, Best Practices in IP Network Security, sponsored by Ciena and Liberty Global. Before we begin, I will cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, please type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you today, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green resource list widget. Near the end of today's presentation, please take a minute to complete the survey that's already open on your screen. Your feedback is extremely helpful. Finally, an on-demand version of the webcast will be available about 24 hours after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Principal Analyst at Omdia, Julian Watson. Julian?
Thanks, Hannah, and good afternoon, everybody, and thanks very much for joining our webinar today. Just a quick introduction from myself. So, as Hannah says, I'm a wholesale analyst focusing on various aspects of wholesale, including IP transit, backbone services, and access to. And I would perhaps like to introduce Antoin from Liberty Global and Patrick from Ciena. Perhaps you'd like to say a few words about yourselves, starting with Antoin, perhaps.
Okay, so my name is Antoin Verschuren. I'm leading the network security team within Liberty Global. Who's Liberty Global? Well, we're a tier 1 network provider and we offer IP transit services. We do a lot about network security. If you're interested in that, pictures on the screen, contact our business services. Next to my work at Liberty Global, I'm also quite involved in the Internet Engineering Task Force, the ITF, working on security enhancements for various protocol, and I'm also chairing the registration extensions working group there. So that's basically my background. Over to you, Patrick.
Great, thanks, Antoine. Patrick Scully, Director of Product Management at Ciena. Ciena is a global equipment manufacturer providing a number of devices all the way from layer 0 to layer 3 to our global customers. In my role in product management, I look after mainly our optical business and anything that is security and encryption related within the overall Ciena portfolio.
Thanks very much, Patrick. So before we move on to a roundtable discussion about best practice in IP network security, I just would like to walk through a few trends we're seeing in this area. So I think we take the internet for granted, don't we? It's foundational to everyday personal and business life. So from communicating with each other, consuming entertainment, transacting with customers, and a lot more besides. So I think what you can see here is the evolution of IP network traffic in France. As you can see, during the time of the pandemic, so specifically in 2020, there was a 50% spike in IP network traffic as millions of people, as we know, shifted to working from home, or they also studied and entertained themselves away from the office environment. But we also saw pretty strong growth in 2021 as well, about 30% or so growth in IP network traffic in France. And I think this is driven by trends that really go beyond the pandemic, trends that started before the pandemic and perhaps have been accelerated. These include the ongoing movement of enterprise applications to the public cloud and the shift of consumer entertainment to the online environment. And these drivers will continue to shift growth in the future. So as we know, the global internet is a spider's web. It's a patchwork of thousands of directly and indirectly connected autonomous systems. And the role of BGP here is to manage the routing of internet data from origination to destination via these autonomous services and back to the internet user. So in theory, BGP will select the most efficient route for steering internet traffic, but there is a fundamental weakness in all of this that we'll hear about more today. And that's the route sharing function of BGP is based on trust. So what does this mean? This means that when incorrect route information is shared between peered or autonomous systems, it's accepted on trust. So when incorrect route information is shared, it's accepted on trust by autonomous systems rather than identify that it's incorrect and blocked at source. So such sharing of incorrect route information is often accidental, and it's down to human error. But there are malicious actors out there that also seek to exploit weaknesses in IP network security, for instance, to redirect users to spoofed websites, to execute denial of services attacks, and even to eavesdrop on communications and much more besides. So I think as we can see from these couple of examples you can see on the screen here, what happens in one country, so some routing incident in one country can have an adverse impact on access to services and user experience in a geographically distant second country. So for instance, in 2018, the Google outage we can see here on the right was a result of an accidental route leak by an ISP in Nigeria. So enterprises and consumers alike are becoming more aware of the importance of security. So each year, Omdia surveys thousands of enterprise IT decision makers across the world on their business drivers and their technology priorities. So we're finding in the last few years as we run this survey that security and the related areas of identity and privacy are really high up on the agenda of IT decision makers. So security, identity and privacy ranked number one of 11 important IT trends in this survey. So this was some distance ahead of other really important trends like enterprises creating a digital capability, adopting cloud services, which is obviously a big trend, and also improving IT sustainability. So a separate survey we've run recently among cybersecurity decision makers also found that 3/4 of 600 or so respondents thought that security issues had become more severe or stayed the same in the last couple of years. So 3/4 thought things were either staying the same or getting worse. So enterprises overall are increasingly aware of both the expanding attack surface and attack vectors and the consequences as well of security breaches, whether the consequences are in the form of data theft, denial of service attacks, or something else. These consequences can span direct financial loss and reputational damage, or degraded user experience when accessing digital services. So we don't exactly assess the financial impact of security breaches of one form or another, but certainly research from IBM suggests that the average cost of a data breach alone continues to rise year over year to about 4.3 million per event in dollars in 2022. So I think as we'll hear today from Antoin and Patrick, proactive security measures aren't just about protecting yourselves and your customers from malicious actors, but it's also about maintaining robust network performance and optimizing network costs by filtering out bad traffic before it traverses the internet. So I think what we might do is just to move on to the roundtable section of this webinar and walk through a few questions that we've considered that Patrick and Antoin have thought about. So I think let's start with, what are the latest trends we're seeing in network security? So I know Patrick, I think we discussed earlier that a few years ago, certainly policymakers around the world and regulators seem to be very very heavily focused on things like GDPR and data protection and privacy. But it seems as if they've now turned their attention to security in the networks and network security. So perhaps, Patrick, you could share your insight on why you think there's increased focus on network security, and what does all this mean from the perspective of a equipment provider like Ciena?
Great, thanks, Julian. So yes, you're entirely correct. There's been quite a shift in some of the security trends that we're seeing in the global marketplace. And when we consider essentially what would have been talked about a few years ago, you mentioned GDPR and data protection, and certainly the kind of information and headlines that would have been seen a few years ago would have been focused on data security, Privacy Act, and we would have seen essentially a number of enterprises being targeted, and the headlines would have been about Enterprise One has been hacked, a number of records have been compromised, and so forth. And while these things still happen, one of the major trends that we've seen is that the networks themselves are a key target for bad actors to try to compromise the flow of information. And when you consider everything that's taking place at the geopolitical level, communication systems are the foundation of a number of systems out there. Whether it's for financial transactions, you're looking at being able to do card payment in the stores and so forth. Well, if the networks are compromised, this can compromise significant portion of the economy, and more so, there's essentially a large emphasis that's being placed on not only protecting the data that is flowing across the networks, but protecting the networks themselves. And to that effect, what we've seen probably over the last 18 months to 2 years is a number of government have enacted legislations that put a number of requirements onto the telecom providers or the network operators. So whether we're talking about the executive order in the US, the Telecom Security Act in the UK, or the Cyber Resiliency Act in the EU, there are a number of new regulations out there that put emphasis and requirements onto network operators, which in turns into requirements for the equipment that is being deployed by these operators. So we've been having a number of discussions with our global customers as to how to react and how to best answer for compliancy for these new regulations that have been enacted globally. Now, an interesting article that was published recently by joint effort across multiple nations is a paper about the principle and approaches for security by design and security by default. And what this paper is all about, talking about how security must be engineered into the products and the network design. So it applies to both the architecture of the networks as well as the products themselves. Essentially, that security must be considered at the requirements phase of the design portion, so that it's embedded into the design of the platforms, so that it essentially provides the best security. Because otherwise, if you're trying to bolt on security after the fact, quite often you'll leave gaps that could be exploited by hackers. The other concept that's highlighted in that paper is security by default, which is all about making sure that the network's engineered and the architecture and the equipment itself is engineered in a way that when it is deployed, a user or an operator doesn't have to go through a 500-page manual to make that device secure in the network and harden its security stance, that all of these security features are designed to be active by default. So these two concepts apply both equally to the equipment that powers the network, as well as the network architecture and design itself. So it's applicable pretty much across the board.
very much. Thank you very much, Patrick. So perhaps if we turn to you, and Antoin. So we talked about some of the BGP routing incidents, briefly in the analyst introduction. So perhaps if you could talk a little bit about, what are some of the security measures that are being developed to mitigate precisely against these BGP routing incidents? Thanks, Antoin.
Thanks, Julian. Yeah, well, there are a number of vulnerabilities in the BGP routing protocol itself, of course. Everybody knows that the BGP routing protocol was designed in the previous century when everybody just trusted each other and everybody was glad when it was already working. So nobody took any effort on building security into the protocol. This means that, you already mentioned this, it's based on trust. Everybody can actually announce a route onto the internet. And when nothing is done, then that route is accepted by anybody. So here you see, a normal traffic pattern when it gets hijacked by somebody. And like you said, this doesn't have to be an intentional malicious hijack. It can also be somebody makes a mistake, then that mistake is propagated over the internet, and it can lead to a lot of mayhem. Here, the example is that you're redirected to a malicious website. You can also be dropping traffic. You could also reroute traffic for eavesdropping on packets. But traditionally, a route is accepted by anybody that sends it. So now the question is, what can we do about this, right? Because the protocol itself, it doesn't have any security things built in. There are some recommendations. I want to highlight here MANRS. MANRS is it stands for Mutually Agreed Norms for Routing Security, and it comes best to, a sort of framework that advises what should you do to make routing secure. And it basically says you need to do 4 things, and I sort of like summarize them here on one slide. First thing you should do is you filter your routes. So that's on the routing control plane. Second thing is you should do a source address validation. So that's on the data plane, that's accepting packets. And you can only do 1 and 2 if you have correct routing administration, because you build these filters based on what you know about another network. So your internet routing, you should maintain your internet routing registry. I will talk a little bit about RPKI, which stands for Resource Public Key Infrastructure, which is a more secure way of announcing your prefixes. And a 4th pillar that MANRS says is you should do something about cooperation. Make sure that you're contactable when incidents happen. Make sure that when there's something wrong in your network, people know how to reach you. So when you do all these registrations in all these different databases, make sure you have the correct email address and the correct phone number. And when somebody calls you, please answer the phone instead of letting it ring or whatever. So let's go to route filters first. And now I clicked the wrong button. So what is route filtering in BGP? Traditionally, so for a number of years, we are using route filters based on the policy that is published in the Internet Routing Registry. So basically, if everybody tells you which IP addresses that they route, you can filter on every connection and filter out the bad things. So you can filter bogons, bad routes, and then the important part, of course, is only accept the legitimate routes. Let's see, what did I do here? I pushed the wrong button. Okay. But in order to do that, we need to know the routes and the prefixes that live in another network where we should accept traffic from. So the Internet Routing Registry is used for these filters. So please be sure that this data is accurate. In the black box, you see, a small filter, how you can create these filters when everything is okay. And you can just put that filter on your connections. But we may have an issue with the Internet Routing Registry, and that is that, the Internet Routing Registry exists for a long time, but historically not all RAR, so the Internet registries that hand out prefixes, They didn't all have an RIR database, and some ISPs started using their own RIR database, their own internet routing registry, and this led to proprietary databases, fragmentation, conflicting data. In other words, the data historically was not well maintained because people didn't see the need for it. But perhaps the most important drawback of the Internet Routing Registry was that the data was not validated or cryptographically secured. So anybody could enter a route in a routing registry without any validation if that was the original intent of the one that owns the prefixes. Some of these disadvantages are no longer there. The RER data is still important, like we will see, but especially the non-validation and not cryptographically secured led to the IETF create another way to filter routes, which is RPKI, Resource Public Key Infrastructure, I already mentioned. So basically what you do is sort of like the same information you put in an internet routing registry, you now cryptographically sign, and you make route origin authorizations or ROAs. And you can, again, create a filter. You validate the route origins before accepting a route. And the good thing about RPKI is that, this does not only protect the link that you're trying to secure. When you sign your routes, it also means that on other parts of the networks, people can also validate these routes. And it means that sometimes you make a mistake with somebody else's prefix, but somebody else can also make an error with your prefixes somewhere else on the network, and you're also protected by that. So RPKI is the latest, I would say, thing in network security. It's quite hot. It started to be deployed quite a lot since 3 years now. So I would advise everybody to look at this technology and sign your routes. So that is the filtering of routes. The other thing I mentioned was source address validation. Basically, this works the same, only the traffic goes the other way. As we all know, spoof traffic is a major source of DDoS traffic, and it's very hard to control. So source address validation is an anti-spoofing method to protect against, this malicious traffic. And basically what it is it's a firewall filter to say, hey, I only accept packets from you that come from your IP addresses. And this works best closest to the edges. Why? Well, because for single-homed networks, implementing source address validation is actually quite easy. You know if it's one link, you know what IP addresses should live on that link. So you simply say, if it's not one of these IP addresses that I gave you, then I don't accept your traffic. There are a number of methods that you can do that with, but like I said, single home networks, this is easy. The only drawback is, if you have a lot of customers, if you have a lot of connections, you really have to implement it on each and every one of it. So it can be quite a task, but it's not too difficult. That changes when you do this for large networks, and especially large networks that have asynchronous routing. So if you don't announce your prefixes to a link, but you do send traffic over it, how can I be sure that this traffic is supposed to come from your network? So the only way here as well is create filters, and these filters again rely on Internet Routing Registry data, because that tells me what IP addresses are supposed to live on the network or downstream of that network. The difficulty there is, of course, large networks change often. They get new customers, they get customers that leave, they get networks added. So these prefix lists, they fluctuate quite a lot for larger networks. So you have to automate these filters to be able to keep up with provisioning of the networks. So we have implemented this for Liberty Global, for example, and we update our prefix filters every 24 hours. This is the current state of affairs, and now we're going a bit further. this will prevent, a lot, I would say 95% of the BGP hijacks that are happening today. But we're not then securing things yet. Route origin validation protects you against, people that are trying to hijack the origin. That's of course true. But there is some other malicious activity, for example, path hijacking. There's at the ITF currently, there's a new protocol or a new best current practice called ASPA, Autonomous System Provider Authorization. It actually does the same as with authorizing prefixes. It authorizes connection. And so you can actually validate a whole BGP path, whether or not this is the intent of the originator announcing the path. And once we have that, we can also do the difficult source address validation for a larger network on a much more automated scale. This is another thing we're talking about in the ITF right now, which is called BAR-SAV. It means source address validation based on BGP update messages, ASPA and ROAS. This is in its early stage, so probably I expect ASPA to be rolled out in like 2 or 3 years from now. And only after that we can start thinking about BAR-SAV. But so that's basically what's in the pipeline for BGP security.
Thank you, Antoine. Just an ad hoc question. So I think what I've heard various webinars about security and defense in-depth security. A buzzword that you often hear is automation. I mean, presumably it is just far too difficult to automate some of these things. Any thoughts on that?
Well, if everybody maintains their routing administration correctly, then we now have 2 methods to do this. So it means we have redundancy. So that's the defense in depth. The one will not go away without the other. You shouldn't bet on only one horse, right? So that's why there are different technologies being developed and deployed.
Thank you. Thanks very much, Antoine. So I think if we move on to a second area. So Patrick, I think you mentioned in your initial introduction the concepts of defense in-depth security and security by design and default. I mean, perhaps you could just talk a little bit more about what some of the benefits of such a defense at source policy is for service providers.
Yes, definitely. So when we look at a concept of security by design, it's really making sure that the security is embedded into the design of the application and or the module, the hardware that is being deployed. The key advantage there for service providers and the network operators really is understanding that the equipment was designed to operate in such a way that with security in mind, and that security was not an afterthought that was added after the fact. A good example of that, and something that we've done in hardware, is essentially when looking at data encryption, the functions are designed so that they are programmed at the factory, and therefore whenever a module is deployed in the field, the encryption functions are enabled by default and cannot be disabled. So that's a good concept of security by design. Is we've designed the product, and that's a way that can be deployed by the operator, that's in such a way that there is no on-off switch for the encryption function. And really, when you think about it, that's quite critical, because the minute that there is an on-off switch in software, this is an invitation for a hacker to try to exploit a backdoor to go in and disable the encryption, as opposed to defeating the encryption. So by removing that on-off switch, essentially removes an attack point. So that's one of the key examples, and that's valid across network design and equipment design when considering security as part of the initial requirements.
Thanks. I don't know whether you can sort of talk a little bit about the fact that actually there's, as well as sort of new networks that are being deployed, new technologies, new routers. There's obviously quite a lot of old routers, old technologies still embedded into networks, across the world. So is there a sort of slightly different approach to sort of making sure that these boxes, this infrastructure is protected against the emerging threats too?
Definitely. I mean, there are a number of tools and audits that can be run to make sure that the networks are operated in a secure manner. Now, I did talk about the concepts of security by default as well. So we see that more and more. Certainly, newer platforms have security built in so that when the devices are turned up in the field, they are secure from the get-go. However, even with perhaps some of the older technology, there exists a number of hardening guidelines that are available to customers. So even though some of the platforms may be a bit older, there are certainly ways to harden those defenses and to make sure that the networks remain secure. So it's essentially a combination of effort where making sure that existing platforms are maintained and kept upgraded to the latest code release to make sure that vulnerabilities that have been identified and remedied are actually implemented in the equipment that's deployed. And also there's some benefit to some of the more recent equipment that embeds those concepts of security by design and by default in the product design and the initial deployment of the platform.
Thank you, Patrick. So perhaps, Antoin, if we talk about, perhaps what ISPs and other network operators, and you mentioned some challenges here. ISPs growing their customer base quite quickly, which sort of means that they have new IP addresses coming on board, or mergers and acquisitions that obviously has an impact on their day-to-day operations. So, Antoin, perhaps you could talk a little bit about what ISPs should be doing to protect themselves and their customers actually now.
Yeah, well, if we look at what customers should be do, or network operators in general should do now, is that to implement all these new routing security measures, the first thing you need to do is you should verify your routing administration. I put a slide up from a famous website, or if you don't know it yet, it's a very handy website where you can simply put in your ASN number or your prefixes that you own, and you can immediately see if you have any errors in your routing administration. So whether it's RPKI missing, whether it's wrong routing objects that you don't know about. If you fill in your AS number, you simply get a list of everything that's known on the internet in all the routing registries about your prefixes. Now, I put in our network here, which is all green, of course, but the handy thing is that when I took an example here of a prefix that's wrong, it works with red, yellow, and green, so it's easily understandable for everybody. If something's red, it means you have an error and there's something that you should fix, and you even get advice. What's the problem with this prefix? What should you do about it? I really advise everybody, verify your routing administration and make sure it's in order, because when there's an error, perhaps you don't have a problem now, perhaps you don't have a problem with your upstream, but if you go to ISPs or if you go to other upstreams, then probably your routes are filtered and blocked. So that's the first thing that you could do. The second thing I would advise everybody to do that owns prefixes is please sign your prefixes with RPKI. This is a technology that is now, evolving for 3 years, and people should really do this. It doesn't take you a lot of work, but it protects you, in all corners of the world against BGP hijacks. I put the example here of the RIPE LAR portal. So everybody that owns a prefix with some RAR. If you go to their portal, there's an easy one-click button saying, okay, this is your prefix. I route this prefix. Please put an RPKI ROA to it, and you're done. It's not rocket science. The third thing I think you should look at is, choose a MANRS compliant transit provider or a MANRS compliant ISP. If you go to the MANRS website, there's a whole list of participants that state what they have done in terms of routing security. And if you choose a provider that is MANRS compliant, then at least know that your upstream traffic is being filtered and is being monitored correctly. There are perhaps some nice things to look at, right? You can actually see if your current ISP is doing route origin validation, if it's doing RPKI. This is a website, is BGP safe yet? You can just click a button and see, is my ISP doing the correct thing? And for those who want to get more involved and want to know, how am I going to do this on my own network? I think this webinar is too short to teach that. So I put up some tutorials and other documentation. Of course, MANRS has some great trainings, but I also want to highlight the right training on BGP security, which I think is very good. If you want to understand all the terminology I'm talking about that, and you didn't understand, they explain it in a very, very easy way to everybody. So that's what, if you're a network operator, if you own prefixes, if you're an ISP, those are the things that I think you should do to become safe.
Thank you, thank you, Antoin. I think some, great practical advice there. Perhaps if I move on to a somewhat similar question, Antoin. So you mentioned, working with a MANRS compliant ISP will give you a good confidence in terms of their policies towards security. But if we think more broadly, perhaps about IP transit services, certainly within Europe, there are quite a few players out there offering IP transit services, from yourselves to some of the incumbents, and then smaller players as well. So if you're an ISP or an MNO, buying in IP transit services, so what type of expertise and experience should you be looking for, I beg your pardon, in your provider?
Well, yeah. So network compliance is one, or MANRS compliance is one. I think people often forget, the importance of security, in the sense that, in general, people regard security measures as cost, and this is not always true. Of course, it's like waiting for an incident to happen, and then only it's considered to be a loss when there's an incident. Want to give you a nice thought about things, that if somebody accidentally starts routing something that he shouldn't do, then this is a mistake, right? 95% of the routing errors on the network are mistakes, and this can happen to you too. So if you are not protected by your upstream provider, every mistake that you make will be propagated to the internet and have a far greater impact than when you have an upstream provider that is protecting you against this. So one of the things you should consider is that, we all make mistakes. Your customers can also make mistakes, and the impact of those mistakes is far less if you have a MANRS compliant upstream provider, or if if you're MANRS compliant even yourself. So you should strive for your own network to be network to be the MANRS compliant. So that's only one of the advantages that you will have. But the interesting thing is that when we started to implement, for example, RPKI validation, we actually found that the amount of incidents on our network decreased by 80%, which means that our network became far more stable. So if you connect to a network that has implemented these security measures, it also benefits you because you will have a reliant and upstream, and there you also have the reputation of being connected to a good network. If you implement these security measures, it's much more than preventing incidents. A network with less incidents is far more stable than a network without. And the third thing perhaps is, implementing source address validation in our network, we saw that the malicious traffic dropped quite a bit. A 20% decrease in traffic for often misused protocols like DNS and NTP, which are mostly used in DDoS attack. We just simply dropped that traffic and no one complained. So everybody on its network has malware infections that generate this traffic. Or you have customers, or you have end customers that are infected with malware and they create this traffic. And if you drop this traffic, it means that in your network, you have much more capacity for the legitimate traffic. So it increases capacity. And the good thing, of course, to our end customers, and also so for customers that connect to a MANRS compliant network, is that because this bad traffic is filtered out, you don't have to pay for it. So you only pay for your legitimate traffic that you're sending, and not for the bad traffic that is generated by mistake in your network sometimes anyway.
So it helps with the sort of economics of running running an ISP as well, and of course, economics is really important in this business.
Yeah.
Thanks very much, Antoin. I don't know whether you've got anything to share, Patrick, in terms of what qualities, what type of qualities you value in your sort of customers in terms of their attitudes towards security. If you've got any thoughts there, and sort of perhaps what advice you're giving to them as sort of new sources of security risk emerge.
Yeah, well, definitely, and that's something when having discussions with customers, and as I mentioned, with the new regulations that have been implemented in a number of countries, we've been having regular discussions with operators to help them understand those requirements, and because a number of these requirements impact the products themselves that get deployed, obviously we had a keen interest in bottoming out the requirement, fully understanding those, and that's one of the value that we've been sharing with the customer is part education in terms of what that really means to their network operations. And I must say that the discussions that we've been having with customers has been quite valuable, and it's information that is shared in both ways, both understanding how they use the equipment and with our recommendation how the equipment could be configured and deployed in the network to benefit them from a security perspective. So it's been a two-way discussion, and really that's one of the approaches that we like to take, is really a partnership with our customers to, especially in the area of security, it's quite important to have open discussions with the customer to make sure that nothing is left to chance, and that we explore those those elements in detail. So it's really about making sure that they're aware of some of the key functions that the equipment will provide, whether it's simple stuff like having a secure boot device onto a piece of equipment, or using loads that are software loads and firmware load that are digitally signed for authenticity. This kind of basic network hygiene really helps operators deploy networks that will be operating in a safe manner. And it's really a collaboration effort between ourselves and our customers, the network providers, to be able to use those equipment and configure them in the best way to, at the end of the day, provide the secure services for their end customers.
Thank you, Patrick. So I would say, if there are any questions from the audience, please do submit them. You can see the Q&A section. So I'm sure Antoin and Patrick would be very happy to answer. So any questions, whether they be sort of general or business related or more technical, but if you feel you want to share questions, after the event, you can do that. You can do that too. So I think that the next question I would like to ask to both of you, Antoin and Patrick, is obviously over the last couple of decades since the creation or the origination of the internet and its proliferation across the world, the security landscape has massively diversified, and new types of actors are emerging and seeking to disrupt networks and access to services, in terms of denial of service attacks, in terms of overloading networks with bad traffic, in terms of eavesdropping. I mean, perhaps you could just share your thoughts on where we see the threat landscape evolving in the future, and how you go about actually helping to protect ISPs and other customers against these threats.
Perhaps I'll start at a high level in terms of what I'm seeing, then I'll let Antoine talk about a bit more details on their side. But I'll see the security and the security threat landscape evolving. Obviously, network security will continue to be a primary focus with everything that's happening. A number of state actors trying to look at ways of destabilizing communication networks and so forth. So security and network security, the data will continue to be paramount. An interesting threat that has started to emerge and been getting quite a bit of news in the press recently has been the threat of quantum computers on network security and so forth. So this is obviously a key element that we're involved in, certainly being as mainly at the forefront of some of these technologies, but looking at what quantum communication and quantum secure communication means for the network. Now, what are the key risks now? What are the key concerns? Educating customers and end users about what those threats are, what solutions exist, and really what are the methods that will be used in quantum communication, not only today but in 5 years and 10 years down the road. So it's really looking forward to these kinds of new technology and how they can influence the security landscape, is helping our customers and the end users at the end of the day prepare themselves for the changes in the security environment.
Thank you, Patrick. Any thoughts from you, Antoine?
Yeah, well, I actually agree with Patrick. Quantum computing is one of the threats in the future as well. What we also see is that while the network grows, it becomes more fragmented. If you only look, for example, at the depletion of IPv4 addresses, then at the moment when you want IP addresses, you go to address brokers and you only get small pieces of addresses, which means that the routing table grows, and it also means that it becomes more difficult and difficult to know all your peers or to know all your filters that you need to build without automation. So without automating your filters, it's not doable anymore to create your network filters. So automation is one thing that we need to focus on. The other thing is that we see also a shift to IPv6. So people create wonderful filters on IPv4 on the networks, but they forget to create the same filters on IPv6. And while more and more traffic is shifting to IPv6, I think the similar amount of attention should be put there. And that's often sometimes forgotten in people that run their networks for a very long time, and they think that there are no new vulnerabilities until the hackers discover that, you know, with IPv6 that door is wide open, that they try to close with all sorts of filters on IPv4.
Thank you, Antoin. So a sort of sub question to that. I think you once or twice you've mentioned, you know, fragmentation, and I think either you or Patrick mentioned the sort of some you know, state actor risks. I think some people talk about, you know, the splinternet, the geographical sort of fragmentation of the internet along geopolitical lines. Is that something that, you know, poses a longer term threat as well? Is that something you're hearing?
Yes, if I can go to first, one thing I forgot to mention is what is the result of this fragmentation, and what's the result to our security monitoring here? What we are faced with at the moment, like I said, 95% of the routing incidents that we see are not malicious acts. They are mistakes, because people manually maintain their network, people don't maintain their routing administration. So 95% of the incidents, the routing incidents that we see, are non-intentional, no harming incidents. But that means that the 5% of the attacks that are malicious are not well spotted, because you don't know if it's malicious or not. It means that they fall into the background when you're trying to monitor your network. So that's the risk of having many incidents that are non-malicious, that the malicious events, they don't stand out. And that's why we need automation and heuristics also to recognize them.
Thank you, Antoin. And I think, Patrick, you sort of mentioned some of the new laws and policies being introduced in various countries to, you know, drive improved network security. And you're sort of advising customers on, you know, what they should be doing. I mean, is there quite a lot of differences in sort of directions of travel among regulators and policymakers? Are some being, you know, a lot more forward-looking and stringent than others? And, you know, how do service providers perhaps go around navigating this type of complexity?
I think that what we've seen with the regulations are not really what I would call earth-shattering or big movement in terms of the security regulations, but essentially implementing and enforcing good housekeeping from a network management and network operations perspective. Things like making sure that deprecated protocol are not in use, and a number of other examples that are used to authenticate devices in the network. So a number of elements that are in existence today as part of the technology, and it's really, in some cases, enforcing the usage of these tools that already exist to improve on network security, and making sure that operators are a number of operators were already doing it because they understood the importance of these aspects. But it's making sure that not only the good ones do it, but everyone does it to make sure that the networks operate in a safe fashion.
Thank you very much.
And in that same sense, Patrick, I think that when the introduction of new security protocols, I think that people also have to get used to new ways of working, right? What I see, for example, is that when people are now moving routes around, they're still used to their old way of working, like they did 15 or 20 years ago. Turn on BGP routing. Oh, and then 5 minutes later or a day later, they realize, we still have to create a route object, or we still have to put on this security feature, but only afterwards. And where I think that with all these new security extensions, there is a new way of working where you have to think about turning that on before you actually start routing traffic. And otherwise, it shouldn't work in the equipment.
Thank you, Antoine. So we've got a question that has come in. I think we've got about four minutes. I mean, it's a big question, so perhaps if you could try to address it in the short time. So question is, what role can data analytics and machine learning play in building IP network security or preventing malicious attacks in IP on IP networks? So I mean, perhaps Patrick, you could have a go at this question first.
Yeah, so when we look at machine learning, data analysis, these kinds of computer-based elements are very good at picking up trends. So obviously, if there's a major event, a human will be able to detect it and so forth. However, machine learning is very good at picking up subtle trends and subtle shifts in traffic pattern that may be indicative of a security attack. So I think that's probably one aspect that machine learning can be useful, is picking up on those subtle trends to flag those to the network operator for deeper analysis. I'm not sure, Antoine, if you have anything to add to this point.
Yeah, well, of course, when we do BGP security monitoring, we already use quite a lot of data analytics. I don't know, machine learning, perhaps it's a bit too trendy line for me. But for example, if I'm monitoring routes or I'm monitoring anomalies for network security, there are already quite a lot of tools that can actually inform you about the state of routing. Here I put an example. If you look at RIPE has a number of tools where you can actually see what's the routing history for a prefix, right? This is also sort of like a big data analytics, where you actually collect all your routing information from a number of route collectors all over the world, and then see what's actually happening here. And by visualizing this, you can explain what the errors actually are, what the routing incidents actually are. And at the moment, I'm seeing a burst of tools to do BGP monitoring. This is an example, for example, PacketVis, which is built on top of BGP Alerter. A lot of tools that try to inform you in real time about any incidents happening on your network by collectively using big data from all the route collectors. So there is already a lot done here that make your monitoring of your network a lot more easier. And since this is the, I think one of the last minutes of this presentation, I put up a slide here with a survey from MANRS, because we are talking here now about everything that we think that we have done correctly for improving network security. But we're actually, and this is a call from the MANRS community, so from all the networks operations jointly. We actually would like to know what your requirements are for network security, whether you see your threats in the business that you run or the network that you run. If you have any ideas of that, here's a link to a webinar. It will be sent to you after the presentation or after the webinar as well. Please fill in this survey so that we can understand better what other technologies should be implemented in the near future.
Many thanks, Antoine. So yes, please do take a look and complete that survey, because I think it's going to share some really important and useful insight for Antoine and his colleagues. So with that, I'd like to thank Antoine from Liberty Global and Patrick from Ciena for your thoughts today on what is a really critical issue, sort of IP network security and how best to protect your networks and services and customers. Thank you also for sponsoring this webinar. As Hannah said at the top of the presentation, you can access a recording in the next day or so, and also you can access the slides, and please do keep in contact with us to discuss your requirements. Many thanks again. Thank you.
Thank you all.